Hello everyone and welcome back to Exam Prep Solutions. In this video, we're going to be going over a Manning's equation flow in a pipe problem. So break out your notebook, give this problem a shot before I go through the answer. If you want a full framework for solving any FE exam problem, I have the guide 5 steps to solving any FE exam problem. You can find the description down below for free. Anyways, let's jump into the practice problem here and let's see if we can solve this one. So we're now in the problem. A circular concrete storm sewer flows full with the following properties: is a diameter of 24 inches, a pipe slope of 0.0015, and a Manning's roughness coefficient of n equals 0.013. What's the flow rate in the pipe? A very standard FE problem here. We are solving for flow rate. Now, let's read the problem carefully. We have a flowing full pipe here. So not partially full, but actually flowing completely full. So there's a small little trick here that we can do to actually solve this problem a little bit faster. But we have on the right the FE reference manual. Just searching for Manning's or Manning is going to immediately pop up Manning's equation. So that's super useful there. So for K, for USCS units, we're in English units, we're going to be using 1.49 for this problem. So we have 1.49 divided by n. Then we're multiplying that by a. R, so A is area, R is hydraulic radius, or R sub H is hydraulic radius, and that's going to be raised to the 2/3 power. And then, of course, the square root of the slope, or the slope raised to the 1/2 power. This is our equation that we're going to be using here. So let's plug in some of the known variables, and then we'll solve for a few of the unknown variables that we have so far. So Q equals 1.49. We have N. What is N? 0.013 times the area. What is the area that we're going to be using? Well, we will be using pi d squared over 4. I'll just use 3.14159 for shorthand, but you guys should be using your test-approved calculators for this problem. So pi d, what is the diameter? We got 24 inches. Now note, the diameter is given in inches, but we're going to be wanting to use feet for this one because what's the flow rate in CFS? It's very important that we stay on top of our units. So pi d squared, it's 2 squared, divided by 4. Awesome. So now we're on to the hydraulic radius. Before we get to that, I'm going to put in the slope, which was 0.0015. So 0.0015 raised to the 1/2 power. I'm just going to put 0.5 there. Now, for the hydraulic radius, which is raised to 2/3, how are we going to solve for this? Now, when a pipe is full, here's a really simple, easy way. It is d over 4 is the hydraulic radius. That makes our lives pretty easy here. Just a little quick hack and cheat there. Diameter is 24 inches. Remember, 2 feet divided by 4. So our hydraulic radius is actually 0.5. Remember, in the equation, though, it's raised to the 2/3 power. Keep that in mind. You don't want to miss that important aspect there. Remember, a lot of these little things, like things being raised to the power and stuff, are things you do not want to miss on the exam. So let's raise that to the 2/3 power now to get our final hydraulic radius. Looks like we have 0.63 for our hydraulic radius. So let's solve all these little bits and pieces here. 1.49 divided by n. N was 0.013. That equals what? 114.615. Then we had 2 squared divided by 4. So that's just going to equal 1. So that's just going to equal 3.14159. That's pretty easy there. And then our slope, 0.0015 raised to the 0.5 power equals 0.0387. So 114.62, we'll just round there. That won't affect our answer too much. Times 0.63. Times our area, which was just 3.14. 159 times 0.0387. And we end up with, okay, we get 8.777. So we round that to about 8.8. Whoops. And so we will be choosing answer A, 8.6 CFS for the flow rate in the pipe. So using Manning's equation, making sure our units are correct, making sure we're not getting messed up with the diameter, inches to feet, and then using that trick for R equals D over 4 for the hydraulic radius when the pipe was full. And we have arrived at our answer there. So I hope that practice problem was helpful. I hope you got that one right. You can check out that 5 steps to solving any FE exam problem. I also have a 90-day FE exam study guide that's also free as an additional bonus. You can find the description down below. If you're looking for direct help with your study, you can also contact me there. Thanks so much for watching, and I hope to see you guys in the next